Good morning, good afternoon, or good evening, whenever this video reaches you. My name is Cassie Hickson, and I attend Chesapeake Bay Governor School at the Bowling Green campus. My project is It Wasn't Me, the Effect of Human Activity on Biodiversity in a Freshwater Marsh. My purpose for my study is to raise awareness of the effects of human activity on a water source, especially since I'm a frequent visitor to the Mattaponi. I'm proposing a theory that human activity and biodiversity are correlated with one another. I conducted a field study of multiple data collection days through 3 levels of human activity to explore my theory. After running my experiment, there is evidence of a relationship between human activity and biodiversity. The data from the high activity site supports the suggested relationship. A little bit of background for my project. Noise pollution has been drastically increasing. It has nearly doubled in the last 4 decades in aquatic environments. Noise pollution has shown harm to organisms through causing stress, hearing loss, and disrupted communication. Long-term noise pollution can also lead to reproducing problems due to the levels of stress. Overall, too much noise can cause organisms to flee their habitat. My alternative hypothesis for my experiment is that the high activity site will have a smaller biodiversity than the medium site, and the medium site will have a smaller biodiversity than the low site. I included a map of my testing locations to help visualize. As you can see, my study was an actual experiment completed on the Mattaponi River. The dot to the right of the map represents the high activity site, where many large boats enter the water at a boat ramp. The dot in the middle represents the medium activity site, where a smaller boat ramp is located that mostly small boats and kayaks use to enter the water. The last dot to the left is the low activity site, which is farther down the same strip of marsh, and only kayaks can reach the site. For my methods, I conducted a field study with a sample size of 4 for both the macroinvertebrates and the fish. My independent variable was the 3 activity sites, and my dependent variable was the level of biodiversity at each site. The constants were the similar characteristics at all the sites, such as vegetation, distance from the land, and the depth of water. This helped me ensure that the human activity was the only difference. Methods for data collection were leaf bags with the microinvertebrates and minnow traps for the fish. The leaf bag was constructed of decomposing matter inside of a mesh bag. The minnow traps were baited to attract the fish in the nearby activity area. This picture here is the trap I constructed with the leaf bag attached to a minnow trap with a clip and a weight to submerge it underwater. The clip with the minnow trap was very helpful with allowing me to take the minnow traps in and out of the water. The fish were just observed and counted once the traps were retrieved from their sites. The macroinvertebrates had a random time sampling pictured down below at the side. The macroinvertebrates were sampled, an identification key, similar to the one pictured, was used to determine the species. The identification key was a very helpful resource I was able to use out in the field. A categorizing system was used to track the different fish species. Each fish species was photographed and assigned a letter. For an example, this fish here was assigned letter A. If any of the other fish that were collected looked like this, it was also counted as species A. These graphs here show the abundance of the macroinvertebrates and the fish. The x-axis of both the graphs represent the activity sites, and the y-axis shows the mean number of organisms. On the macroinvertebrate graph, the high activity site has the greatest abundance, although there really is not much of a difference between all of the other sites. The high activity site on the fish graph has the lowest abundance, which this is what we originally predicted. This indicates a less amount of organisms in the area, which is most likely caused by the high level of human activity going on. The next graph shows species richness at each of the sites. Species richness is simply the number of species at a given area. The y-axis displays the species richness value. As you can see for the fish in green and the macroinvertebrates in orange, that the high activity site has the least number of species, which correlates to having a lower biodiversity. This graph displays dominance at each of the sites. Dominance is a calculated index that shows even representation between species. For an example, a high level of dominance indicates one or a few species dominates in that area. This is the cause at the high activity site for both the fish and the macroinvertebrates, which explains why our first graph, the macroinvertebrates abundance was so large. High levels of dominance correspond to having a smaller level of biodiversity. Shows the Shannon Diversity Index at each of the locations. Shannon Diversity Index is a biodiversity measurement tool that includes both species richness and dominance. The y-axis has the level of Shannon Index. The high activity site has a low Shannon Index for both the macroinvertebrates and the fish. This indicates that the high activity site has a very low biodiversity. Overall, the high activity site has much lower values than the other two sites, since the p-values were not significant in the abundance graphs, and I had a small sample size. My study is not fully representative of the population. However, there is evidence from the other trends that human activity affects biodiversity. In addition, we can expect an organism to adapt to the high activity site and dominate in that area. Certain conflicts constricted my experiment, such as tide changes and mood phases, affecting my data collection. After dealing with a low tide and having the traps out of the water, we stationed them to ensure that they would always be submerged. Perhaps if my experiment was ran again with a larger sample size, there would be more significant data. After revealing my results, I recommend people be aware of their impacts on a water source and try to limit their time out on the water. However, if you do enjoy spending your time on the water, try to swap for a quieter boat or a kayak to limit your noise pollution. The most important thing that I learned and observed during my study is how humans impact other organisms, and this will cause me to be more aware of my actions. I would like to thank Dr. Goff for providing me with my resources and all of his endless help. From his friend for coming out almost every day to help me collect data, Lord Disa for helping me design my project, my boyfriend Cameron for hauling the kayaks every day to the river, and of course, all of you for taking your time to listen to my project. Are there any questions?